read DHS documentation guides, especially DHS Recode Manual. If I have my way now, I would have loved for you to go to that site. Just go Google it. Google it. DHS Recode Manual. You must go through it. It's an avenue for you to understand the nature of the variables, all of the variables, okay? How they were measured and things like that. So there is that DHS documentation guides, especially the DHS Recode Manual. Number 2, when you have not initialized data for analysis using SBY set, you understand, survey set, are you remembering some things now? Survey set range of commands. Why? Let me ask that question. On the basis of what Mr. Hassan taught us yesterday. Why this second bullet? Why do we have to initialize data analysis for survey set range of commands?
For waiting.
For waiting. What command are we expected to do here when we talk about SBY survey set? Anala no money. It's for waiting. Okay. Why do we have to wait? Why do we have to wait?
Okay, to make sure that the data is proportionate, like to give a level playing ground to the data, because during the data collection, there's a possibility that you have collected more data than needed in some areas and collected more data to make it proportionate.
Okay. Any other? Okay. Any other? And as also correct?
Also sampling error.
Sampling errors, good. And at the end of the day, when you are making your conclusion, you have enough confidence to say, I am concluding over the whole of the country. Okay? When you have not read the basic information and tables in the DHS final reports, was it yesterday or today I was telling you that you need to go through the DHS final report? I prefer that you download the full report. In fact, it is that final report, so it has to be final report. There is the abridged version, not so much, okay, but there is also the final report. So, and why do we have to go through the final reports? That is available, yes. What has been done? Should you want to do anything on the analysis, you need to also compare what you have done with the table they also have generated. The moment it tallies, then you know that you're on the right path when you're analyzing. Okay? You do not know about the use of correct weights to use or the weighting procedures. What does this mean? Mr. Hassan mentioned it yesterday when we were dealing with IR. I mean, is it IR or IR? Aha, that is for IR. He mentioned something like that yesterday. That there are different weights for. Yes. You remember that? Aha. So when this one is, you say use of correct weights to use or the weighting procedures. All right. When you don't understand how to handle missing values, this is very important. I can give you an assignment on that. You can also Google it. The different types of missing values. Random, blah, blah, blah. Google it and get to understand it. Do's. Ensure that you properly registered for data access on Measure DHS website and get your own data files and not the African version. Huh? How do we do this? Which is not strange to anybody here, right? At least you did this, is it diploma or certificate, whatever, that you need to score at least 80. Did you do it? Not everybody. Why? Why not everybody? Who has not done it? Is there anybody who has not done it? You have not. You have to do it. In fact, you must do it between today and tomorrow. By Kilo Shele. But I don't think you need that. What you need is to go to that website and you want to, all that involves is that for you to read, from what they are, presenting to you. At the end, you'll be asked to do an exam, which is also computer based. And by the time you do that, you pass if you score 80 and above. Otherwise, you go back again and read. It happened to me before. Is a condition to become a DHS fellow. So you have to keep doing and doing until you score at least 80. Okay, and but it gives you more, opportunity to understand some of the things in there. Okay, you always retain your original data file. Why? On the basis of what was taught yesterday.
You don't want to overwrite it, so that you can always go back to it.
You don't want to overwrite. Okay? So that you have your original data somewhere and then you don't make any mistake along that line. All right? So, you always retain your original data file unmodified. Save as a different file name. So that if anything happens, you know that you still have that data somewhere. Now, check the frequency tabulation of each variable before further analysis. The mean, the bivariable, or multivariable analysis. How do we do this? Just compare it with what is in the final report, and that gives you enough confidence. You understand basic assumptions, limitations, and interpretation of statistical method you want to use. We cannot overemphasize this. Once you are not using non-parametric statistics, you must understand the nature of the assumptions underlining a particular technique you want to employ. Confirm your results at first before building your do file, especially when you are recording variables. How do we do this? You remember we were taught to open a page that has to do with do file. Those are a file containing all the commands you want to run, including those ones you don't want to run, but you want to understand what the next command wants to talk about. That's where you are not putting star or star or thereabout, as the case may be. So that in case you ask the system to run everything from the beginning to the end of file, the system will jump those ones that has to do with star. Okay, because star is actually for you to remember what did I do here. Okay, so ensure you are able to replicate some tables in the final report before proceeding into further analysis. In fact, I think the best thing is for you to get the final report, look at a particular table, then go into Stata and run the same table. Okay? Run the same table. Bring it to your memory that you need to do the necessary weighting. Okay? So in that final report, if you are under individual under IR, okay, get to understand the weighting that has been used, run that analysis yourself and compare if there is any issue. You remember yesterday Mr. Hassan showed us a situation in which we added weight, a situation in which we did not add weight, because most of the time, in fact all of the time, the total sample size will be the same. But when it comes to the categories, there can be variations, and that's what we need to take note of. E.g., current use of contraceptives among ever married women. Does your percentage and N tally with the percentage and N in the final report for that variable? So these are things that you look into when you are running your data. Descriptive analysis or descriptive statistics always come first. It's about data presentation. Tell us what the univariable analysis looks like. Okay? So DHS final reports provide a wealth of descriptive statistics about the most commonly used indicators. What are indicators? What are indicators?
Like measures of progress or
When I was younger, when they talk about indicators, I always think of, what are these people talking about? The day I got to know that they are talking about variables, I said, so let him one time enjoy. It's variable. Somebody mentioned it, but that confidence is not enough. All right. They also provide sample sizes, that's the denominators, for calculating them. Okay? You always need to make sure that your sample sizes and indicators, if same, match those in the final report. Why do you have to do this? Match those in the final report. It's all about confirm your results before building your do file, as well as ensure that you are able to replicate some tables in the final report, okay, before proceeding. I guess that's the last one. So you now know about do's and don'ts, okay? We will continue now, believing that you will be able to do do's and don't do don'ts. Okay? Thank you.
Thank you, sir.
You're welcome.
Next.
Mo fi 200 yọ àkọsá fún mi. Ti yọ ni. Mi ò rí lọ́wọ́. Thank you very much, sir, for that wonderful presentation. So, I think the background speaks for itself. So, we'll be proceeding to where we stopped yesterday. See here. Can you see this one? This is the data. I've uploaded it online. It's just to share, and network is not connected. I don't know why. It just stopped. I'm going to try using my, and the size is about 300 here after zipping it. So you just unzip when you download and start using it. But for some reason, my networks are not connecting. Can anybody share his network?
The network is working. That's stopping them. What to it?
How come I did not have this or this one? And I work here. This new one you just gave me. So when you leave, will you still stay behind? Yes. When you leave, will you still stay behind or it will go with you?
Yes. Is it the same password? Is it based on the same? Wi-Fi is working.
I don't know. I can't explain it. So let me just. I want to share the link so that people can, those who do not have, can go there and download. And while we are working, they can join us. I don't even understand the question you're asking. Can you? Do you remember? We did log in your file as text, waiting, explain why we need to wait. For the reason is the sampling error, like Dr. Ade mentioned, and then the use of service set for declaring your data as a survey data before you proceed with your analysis. Now, we want to go to the next slide today. The next slide is about data transformation. I think we've done a couple of things around this. We have renamed, haven't we renamed? We have recoded, right? We have replaced, have we?
Yes.
And we have generated. We have done label define, right?
Yes, sir.
People are not responding. We have done label define, right? We have done label value.
Yes, sir.
When you label define, that means you have defined the options of a particular variable, like we did for that CEB that we regrouped. We define the value labels, and then we now imposed it on the newly generated variable. We did that yesterday. Some people are looking as if they just came today. Let me open status so that I'll remind them. So, the do file. I'm opening a do file now. The do file is this. So if I clear, do you all have your do file now? This do file. Do you have this do file now?
What you said no.
Yes. No, the one I shared yesterday.
Yes.
Do you all have it?
Yes.
Okay. People are not responding. Did you not see it yesterday? I shared it now. So I want to follow the procedure. That's the essence of using do file. All of these things now would have been gone if you had not used the do file. So if you had used command, all of them would have been gone. So now we can.
So I think the question should be, do you know how to bring it in? That should be the question. You have it on there, rather than downloaded it.
It's not even bringing it in. They are not confirming where they have it in the first place.
Okay, they have,
So if you have it, let's follow me. You have opened your status, right? If you have opened your status, go to do file here, the new do file icon, which is here. Click it once. It will bring this out. This is where you will come to. This is the new do file editor. Open the new do file, and then when you open, this window opens up. Then you come to open here. See icon open, or you go to file and do open. It's still the same thing. So if you say open, it will take you to your last working directory, which was this. If you have changed it, that means you need to go back to that working directory that we use. Just locate it. So you click it, double click, or you click once and then open. So the next thing is to now bring in our data like we did yesterday. Have you seen the new file I shared now, the link I shared for those who do not have Stata?
Yes, it's already here.
Okay, the link that I shared just now.
For the Google Drive.
Yes.
Yes, it's here.
Have you been able to access it, sir?
I don't need it.
Just let me try if you can access it so that I will confirm that others too can do.
Okay, the download link is there. I'm downloading it.
So if you can download it, then others too should be able to download. If you cannot download it, it's like you are using Glow or Etisalat. You need to change to MTN. So let's just continue. For those who see, if you are not able to download, if you are having trouble doing that, just come and join somebody who has a system and is working on it. It's better. No, I'm not mentioning anybody's name. So you clear all just to remove everything in the memory, and then you highlight to do Control D like we did yesterday. Now change directory. I don't know whether you change it or not. The last working directory is what this will be making reference to. But just to fulfill all righteousness, let us test it again that working directory is what we want to use. We have done it yesterday, so let's just continue to highlight and Control D. Use your Control D or you.
The two file we downloaded is a sound of web, so we need to look at our.
You need to put it on your desktop and. Yes, that's what you will see here. So but you need to trace it back to your own directory. Change your directory. Put the right address inside that quote. So if you have done that, now log in your file so that we can see it as text. That's how you use .log. Without that .log, it will be putting your results in that directory as SMCL format, not text format. And the reason we have replaced there is such that when you have that name, file name in your directory, that replace option will help you to replace that current file name. Instead of having to rename it in another name, you can just use it as a form of append. You replace it, and all the things you are doing from the beginning will also be part of your analysis henceforth. So if I say Ctrl D now, that has done. Then I want to import my data, select data for use. And the name of the data is like MGIR7AFL. So I use USE. That's what I used to bring in the data. You tell data, use this data. Then I Ctrl D that, and my data is in this data. Now we need to generate weights, such that every analysis we do, we want to apply weight so that it can be a true representation of reality. So you Ctrl D, you run this. What do you see when you do that? When you do that, it's tell you generate weight like you've run. Then you declare your data as a survey data, because DHS is a survey data. You declare it like you see on the screen. You run it. You can see it. It's showing you the weight, the structure of the data, the strata, sampling units, and other information. Now the next one, to do an example, we ran. This is an example of running frequencies and percentages of your data. A way to explore your data is by tabulating to see how it is distributed. So an example is this: to tabulate children ever born. You can see like we did yesterday. I'm trying to go over all the things we did yesterday, and so you can see that the importance of using do file is very, very huge, so that you can always continue from where you stopped the previous time rather than starting all over again. The next one is how to generate new variable from existing one. We did that yesterday. An example is this: children ever born that we used yesterday, we recoded it into categories. I started from explaining why they said you should always collect your data at the highest level of measurement, which is at ratio level. This is the same as that of these children ever born. So we can recode from that level to a nominal level, which is the categories of number of children. So we have recode V201 equals, that is such that 0, anyone with 0 value in the children ever born, we told data to give you the code as 0, and then name it no child. The second one is those who have between 1 to 4 children, code it as 1, and name it 1 to 4 children. And the last one is those who have from 5 to maximum number in children ever born. In this case here, which is 17. So you can see 5 to 17. That's what we did here. And the first one we said 5 to maximum, because the maximum here is 17, so it's still almost the same thing. So we name it 5 and above, and that's how we continue. And the option you now give the command is called generate. After you have identified those categories, you have given the codes to the categories using the command I showed earlier. So the next option, the option we give to that to generate a new variable from the old one, which is what we wanted to do, is to say generate, then you give the name of the variable, the new variable you want to generate. In this case, CEB group, GRP. And that's what we did. We ran this. And then it has shown you that record V201 and all of that has been done. So if you tabulate the new variable, which is this, you see the new categories of those variables. If you want to add codes to your analysis such that your descriptive analysis, your frequencies and percentages, such that you have the codes you have assigned to each of these categories, you want this to show, that's where you use this number label, num label, comma add. You are telling Satan that you should add number label to the categories of options in your categorical variable. So if I run this now, that's what it will do, but I'm not going to run it. Because it will want to, we have more than 5,000 variables here. So all the categorical variables that have, all of them that have levels, it will want to assign those numbers to it, and it will take time before it finishes. So I don't want to
run non-label for a single variable.
For a single variable. Number label, let me try, because it's not number, I've not done it before. So number label, let's say V106. V106 is level of education, I think. Okay, level of education. Okay, we should use CEB group. Okay, let's do that. Okay. If I tabulate this now without it, and so if I want to see whether this comma add, so it will work. So it is just one that you have specified like that. So it, since it run like this, it works. You can see. So stata is something you can explore and apply just the basic knowledge and see. I've never done this before, and when he said that, I said it should work because that's the idea. Sometimes, let me not go too far. So, so that's how it works. If you want to see for just one variable, like we have done now, you can just say number label that variable. But if you want to do, let me even copy it and replace. You can also update this in your own. I'm not going to share this zip file.
Right.
So you already have the original. So be following it and be putting it there too, and be running as I'm running. Don't expect that I will share it too. So I will share it for you. So let me update this. This is for show value label for CEB group only. So value label for all categorical variables. So that is that. The next one, so another way to generate a new variable is to start with to generate the variable and say the variable equals dot. That means in that variable there will be nothing. So if I run this now and say Ctrl D and then run again, tabulate it, it will tell me no observations. So for me to put the codes for each of those new categories there, changing 0 to 1, 1 to 2, and 2 to 3 under CEB group, I just need to replace this, replace CEB group 1 recoded. The new variable is CEB group 1 recoded. I said you should replace it equals 1 if the previous one, CEB group 1 equals 0. That means anywhere it sees 0, it will put it as 1. Anywhere it says 1, it will put it, change it to 2, and anywhere it says 2, change it to 3. It's just for you to understand how you change value labels in your variables. So I'm going to run all of this once and for all, and then tabulate that again, and you can see what happened. Did you not run? CEB recorded. Did I remove anything? You're welcome, sir. What is the problem? What is going on? I'm asking Stata, is not answering me.
We are experiencing the same.
You are experiencing the same. So let me run all of this again. Let me drop that variable. If I run this, for instance, no observation. Now, if I so if I drop this, we have not done drop before, so let me just drop. No, it's not this one now. All of you are not saying something. Are you not following me? Recorded. So if I drop it, see, it says that variable has been dropped, so it's no longer there. It was saying no observation before. So if I run it, it will say the variable does not exist or something. So the variable not found. So what I want to do is to do that again and understand why it is telling me no observation. So now let's generate that variable again. The variable recorded. So we have generated it. If we run it,
You need to slow down.
no observation. See, we are going over this because it was telling me no observation after I had changed the value labels For now, does that variable exist? CEB group 1 recoded, does it exist? Yes. I have generated it. So for me to know that I've done that, I just need to tabulate it and see. It says it exists, but there is no observation. And that is true. Sorry?
Okay, so
because we only generated here. Now, I didn't get what you said.
No, it's bringing out an error means that it's already defined.
Because it was in the data since yesterday. We developed that. So, now, there's no observation. And for the first one, I said, let's see. This, we are saying CEB group 1 equals 0 here. Where is CEB group 1? This is it here. There is nothing there.
No observation.
Yes. And the reason is because, did we run this?
That's the problem. I just discovered.
Because that CEB group 1, there is nothing there. We only ran the first one, we did not run the second one.
Me, I have CB group 1.
Did you run it?
I have it. Yes. No child, 1 to 4 children. I have this.
Let me run it here. So now that I've run it, it is here. So if I replace CEB group 1, which was 0, if inside the new CEB group 1 recoded, so I will say replace, because you know we generated the CEB group 1 recoded here. Let me move this aside. For those who are not following us properly, this CEB group 1 recoded, we generated it from where? From here. At the end of the day, we tabulated it. It gave us this. No, this is for the group 1. So for the recoded, we generated it here. It's a new variable that we generated. And when we run it, how did we generate it? We just said, generate it and put nothing inside it. That's the dot. So if you tabulate that one, that means there will be nothing there because we told it to generate and put nothing there. So that's why it is no observation. For us to now put something in it, we want to do that based on the previous variable that we already have labels for, values for, which is the one here, this CEB group 1. So based on this, we want to say, okay, where you see CEB group 1, where it is 0, replace that inside this CEB group 1 recoded with 1. That's the meaning of the first one. The meaning of the second one is where you see 1, where the category is 1 under CEB group 1, replace it with replace it with 2, and where it is 2, replace it with what? 3. So if you go and tabulate that one after running this command, you will get what you are looking for in terms of the recoded variable. Let me put it here so that. So if I say replace this, you will be seeing how it is doing that thing. See, 11,829 changes made. So if you run the second one as well, see the numbers, and if you run the third, you can also run everything as once. So when you tabulate, and if you want to run everything as once, what do? You just highlight those ones you want to run. And then if you tabulate it now, it will bring out the codes for you. So we are looking at the new codes, the 1, 2, 3 here, 1, 2, 3 here. You are looking at them here now, in the new variable CEB group 1 recoded. What's wrong with this thing? So when we tabulate this, what we get. Now, what is 1, what is 2, what is 3? We don't know. So you need to do label define. That's the essence of this. So when you label define, the name you give to that label is CEB define. You can give it any name you want. Just make sure you know what the name is. So here I'm giving it the name CEB define, where 1 equals no child, 2 equals 1 to 4 children, and 3 equals 5 plus children. So this is the definition of the values. Now, to now impose the definition on the variable that has no label here, which is this variable, what you need to do is to run lab val, this is label value CEB group 1 CEB define. That is, this is the new variable. This is the definition that you just developed here. So you impose this on this such that the new labels we have here will be on the new variable. Instead of saying this, we now be having these codes: no child, from 1 to 4 children, and 5 plus children. Is it clear? We are moving on though. Where am I? Okay, I've talked about this, so I'm running this. So if I run this again, it has changed. So that's what I am talking about. Now let's move to the next one. We have not even started today's work. Now, to drop variable. Okay, I've not finished. Let me finish this. I think this is the next one we'll do today. Now, to generate a variable exactly the same as an existing variable, what you need to do is just to say generate. In this case now, the new variable is what? Generate children ever born. This is the short code I gave it. Generate children ever born equals V201. The same thing that is here is what is here, because I just said, okay, create a variable and let it be exactly the other variable, which is V201. This is important in situations where, of course, when you just want to recode and do any manipulation with the new variable, so that you keep your existing variable, which is V201 here. The next one is difference in weighted and unweighted results. By the time you tabulate this and using the weight, we saw the difference yesterday. You tabulate this and this variable, this command and this command, you notice that there are differences across the distribution, across the levels. I mean, in the distribution across the level. Is this okay? Difference in weighted and unweighted results with cross tabulation. Yeah, just as you did in just univariable level, at bivariable level as well, you see the difference. The distributions will differ. Now, the next one we are going to do today is to learn how to drop variable. For instance, this is important. Look up. To drop, there's a command called drop and there's one called keep. They work in reverse manner. So if I need a variable in my analysis, I don't need others. What I need to do is to either keep it and leave others out. And if it is drop that I want to use, I'll just say drop all the ones I'm not using. So in other words, I'm saying keep the ones I'm using. So they are just these commands in working in opposite direction, but essentially doing the same thing. So for instance, if I say drop, I can drop variables. I can also drop part of a particular variable. I can keep variables, many variables. I can also keep a set of variables or even some part of a particular one variable, depending on how you command Stata to do it. Let's say, for instance, I want to drop, let's talk about dropping one of a particular set of variable. Let's say group now, age. What is the variable for age in DHS? Do you know? Do you know? Current age, yeah. What is the variable? V012. Yeah. Tabulate. How do you know? What? Very good. Tabulate V012, right? This is the single years. So the next one will now be V013. That will be usually the DHS. It follows like that. The group will be 13 instead of 12. So if you want this, you see that it is. Is it clear? So now, if you want to drop, let's say those ones. Let's first of all look at the the code for each of those categories, what do I do? If I want to look for the code for each of those categories, 15, thank you, number label V013, right? Comma add. Sorry? Or code book. Okay. So if I do this, what did you say? Value label V013 not found. What if I do tabulation V013 and then no label? If this one runs, why is it that you did not find the label before? Sometimes they will do things like this. So another way, if it gives you this type of issues, is to say no label. But this one will not be showing you both the code and the label. Unlike the non-label comma add. I don't understand why he said this anyway. So for say it again so everybody can hear. Code book V013. Right?
Yes.
Can you see? But this is extensive. You get more than what you need. But at least you have an idea. So for ages 25 to 29, let's say in respect of national policy, Nigerian national youth policy. Is it Nigerian national youth policy? Or Nigerian national youth policy? Is it correct? Yeah, I think it's correct. Nigerian national youth policy, 15 to 29, right? So what's the code? Which are the ones that do not fit into this interest? 15 to 29. We are having 30 to 49, right? So we only need between we only need from 1 to 3, leaving out 4, 5, 6, 7. So if you want to remove 4, 5, 6, 7, what do? You can use logic. That's why I said, first of all, let's just see the code. And we have seen the code that, okay, we don't need from 4 to 7. Now, this is how you go about that. Go to your do file. We only want to focus on 1, 2, 3. That is 15 to 29. So how you do that? How you do that is by keeping or dropping. What I need is to say keep if V013 is greater than what's greater than what? 3. Is that not it?
Less than 3. Keep if it is less.
Keep is okay. Keep if it is less than 3. But if I want to use greater than 3, what should I do? I'll use drop. Do you get? Yes. So in this case now, because I'm interested in 1 to 3, I have to drop if this, or let me put that one too, or keep if this
Does not capture 3.
is less than or equal to, or you say less than 4.
Okay.
You understand? You get it now, right?
Yes, sir.
Yeah, but that means 3 is not inclusive in both, in none of them.
No, 3
The first one, drop if V013 is greater than 3.
3 is there.
1, 2, 3 are there. So if
It's not greater than or equal to. It is greater than.
The first one.
Doctor,
And 3 is not in. For the first one, drop
It's
is
three
greater
better
than.
but we are not interested in anyone other than 1, 2, 3. Those are the ones we are interested in.
Okay, 4, 5, 6.
We don't need those ones. 4, 5, 6. Those ones are greater than 3. That's how we are dropping them. Look at it.
So that's why we can thinking about the reverse of it.
So that's why I use both drop and keep so that you can understand.
Yeah.
So if you are using drop, that means you are dropping those ones greater than 3.
Yeah.
If you are using keep, that means you are keeping those ones less than 4, or yes, less than 4, or you say less than or equal to 3. You get?
Yeah. Or 1 to 4, 1 to 3.
These two, they are the same as. Maybe I should put everything there. This is the same as drop if is. If I'm using
Sometimes when you continue, when you look at this kind of thing, sometimes you make mistake and you have dropped and you discover that 3 is not there. At that point in time, the best thing for you to do is to clear.
And then reload your original data.
Clear, reload, and you run your do file up to that place. Then you now correct your. But sometimes some things like this.
I was going to ask that.
Some things like this will happen and they are dropped. And
So if you drop variables that you probably did not intend to drop. If you drop,
don't say, but I think it's still better.
Yeah, that's the advantage of this profile.
if you mistakenly drop any variable you don't intend to drop, what you need to do is just to clear everything. Since you have your do file, just start running from the beginning till you get to that place and you correct it. So thank you for that. So the next one is okay. I wanted to say drop if v013 is greater than 3, and if you say drop if v013 no, let me not go through that process. At least I've established the possible two scenarios.
V013 equal 1 to 3. It deleted the whole thing. No observation.
I don't understand.
I tried keep if V013 equal 1 to 3. It deleted the whole observation. That's 1 to 3. 1/3.
So you deleted the whole observation.
Everything. 41,821 observations deleted.
Run it again and see. It is like from 1 to 3.
No observations.
From 1 to 3.
Equals means something then.
That language that you
I was surprised.
But he's not supposed to do that.
He's not supposed
He's not supposed to do
I was
that.
surprised.
What was equal supposed to be?
Equals is being specific about the code of the category you are interested in. If I say replace this if this equals, I will go into that variable and look for this code wherever it is. Do what I am asking you to do. And from what she just did, I don't think it should delete everything. But let's just follow what we have here. You can't know all of this is. You just keep exploring and exploring. You get to know it more.
We are not negating each other. Equals. So maybe
No, equals means specific.
just as I said.
So the next one here, so we have talked about dropping and keeping. Okay, let me do it so that I can see what I'm talking about. Drop if. For instance, look up please. Let me run this. Tabulate V013 and then add width. Let me add width too. If I run this, you can see it here. So if I drop if V013 is greater than 3, it has dropped that. If I run that variable again, it will only show me those ones that we are interested in now. So which is 1, 2, and 3.
So I found out that if you do keep if V013 equal 1, V013 equal 2.
That one will work.
So keep
That one will work. I think if you use drop too, it should work. But is I'm saying, why is not allowing for you to abridge it? That's I don't understand why that is. But that abridge one. Okay, now that we have dropped, let's go back and bring back our data. It will tell me I have logged this before, so let me log close.
Have we dropped?
Yes, I have dropped. So you can do your own too and confirm what I just did. So I need to run all of this again.
Yeah, we keep.
You can also keep. I forgot that number leader.
I kept, and everything is gone.
Everything is gone.
Yes.
Everything is gone.
Yes.
You get what?
If this zero,
013.
Did you say keep if V013 is what? 1 to 7?
so I use another variable 103.
103.
Yeah.
Instead of 103.
Instead of 013.
Why did you tell me?
For that 103. I don't know what's the 103.
Oh, okay. You may not bother.
Yeah. Since I'm not going to say.
You are not using the ones.
So, you did not tell me to smile. Okay. All right. It's still loading, see, and that's why I did not want to run that number label the other time. Look at this here. Yeah, it has finished. Just delay and delay. Now, will I be able to collect personal copy?
Yeah.
Okay. I need to save myself. So, we have worked on dropping and keeping. Now, let's move to the next one. Okay, we have done drop, we have done keep. So we have done whether you are focusing on subset of a particular variable. That's what we did here. You can also drop a full variable. You can say drop V013. You just drop that variable. You understand? You can also say keep this variable. It will remove other ones. And you can drop multiple. You can keep multiple. If you have identified all the variables that you want to use in your literature, you have seen age at first birth, you have seen education, religion, and all of that. You know the variables. You know the variables for each one of those. You just say keep V0 this, V this, V that, all of that. You identify the variables, and then you say you run it. When you run it, it will only keep all those ones you have identified and drop the thousands of other ones. You understand? So your data will now be very small. Let me tell you what I'm trying to say. I have seen that, okay, I'm going to be using education, for example, I'm going to be using education, that's V106. I'm going to be using children ever born, V201. I'll be using region, V025. I'll be using place of residence, V024. Anyway, you don't have the two. So these are the variables I want to work with in my data, in my analysis. I don't need to keep all these variables. All these 5,300 and something. See, 5,399 variables. I don't need them. All I need to do is just to keep. And you know, in DHS data, there are some variables that you will not drop because you will need them for weighting and declaring your data as survey data set. Is that not so? So those ones will be naturally be part of those ones we'll keep. And that is what? V005. Do you remember that you used to calculate your weight? V021 and V022, right? Right? Yes. So that means along with other variables, key variables that you want to use in analysis, you need to keep V005, V012 and V022. and then these are your own variables that you want to work with. So once I say keep this, see what will happen to my variables. So see the number of variables I have left. So I'll just focus on this and start my analysis. See, you only have 7 left in your variables, but let me just clear again. Log close. Okay. Are we working together? Okay. Now, this is to keep the next one.
To keep data.
It's going to keep a range and all of this, but by the time you have done replace, you have done recode and all of this. So let's go to the next slide. Now, determining your sample size. Determining your sample size. Let's use a topic to do this. It depends on your target population.
Let's use your topic.
My topic. Why? Why my topic?
Okay, use my own.
She said use my own. I know that's why. I said use my own. Okay. So selecting your samples are, normally for all of us we have all done research now, and I'm sure some of us have used the primary data. For those who have used primary data before, when you want to defend your work, they tell you how did you calculate your sample size. You have to justify it. So for you to come up with the sample size, you need to make it statistical. What did I say? You have to be able to justify, and the way to justify that is by telling the formula you have used. There are different formulas for calculating sample size depending on the nature of your work. So there are some comparisons there are some sample sizes that you use when you are comparing one group to another. There are some. So there are some you use only when your population is more than 10,000. If it's less than 10,000, so there are different sample sizes. So you need to be able to justify that. But luckily for us, using DHS, we are not using any, because the methodology has done that for us. All you need to do is to break down the larger sample into the unit of analysis of your interest. So that's why you see it depends on your target population. If you are interested in adolescents age, like somebody said, unmarried adolescents aged 15 to 19. Your focus now is on adolescents, right? Are you going to also retain only unmarried adolescents or not? Let's come up with a title in that respect. Who was working on that? Somebody said something on unmarried adolescents. Okay, give us the
what?
The title.
The title. Determinant of unintended pregnancy.
Of unintended
pregnancy.
Unintended pregnancy among unmarried adolescents in Nigeria, right?
Yes.
Now, determinants. Are we together?
Yes.
You are happy.
If you were like
Determinants of unintended pregnancies among unmarried adolescents in Nigeria. Adolescents here, because the DHS started from, the age group involved
This one
is from 15. When you say among unmarried adolescents, unless one say among young, unmarried young women. Adolescence is part of young women. It goes from 15 to 24. And that means among unmarried young women. Is it young women or young mothers? Because they are different as well.
Some of them are not being a mother.
The thing is, sometimes there is this emphasis on. Okay, on it. This is not contraceptive. Don't let me distort your brain. No, not book.
Too much data.
No. It's too much engagement with contraceptive information. That's the issue. Because you know it's contraceptive. It is too much. So now, determinants of unintended pregnancies among unmarried young women in Nigeria. First and foremost, what are the key things we want to identify? You must do that first and foremost to get your sample size this time around. We want to look at key focus now regarding sample generation. So the first one, we are looking at unintended pregnancies, right?
Yes.
And that is the outcome. Are we going to focus only on unintended pregnancies? What will determine our sample size? I just want us to understand the process. We are saying the topic is determinants of unintended pregnancies among unmarried young women in Nigeria. If you want to, what is the unintended pregnancy in this title? That unintended pregnancy, what is it? It is an outcome variable, right? So that is not what we are going to be using to select our sample size. That's what I'm driving at. Is our outcome. So it is the outcome we are looking at across different groups. And what are the groups? Unmarried young women. Is there any other thing there? There's no other thing. So our focus is and young, unmarried and young. So we are looking at unmarried. So we are going to be looking at a variable there that is talking about marital status. Are you with me? And then the other one is young women. Is it that I'm tired or what? It's too early. Young women. That's about variable what? About age. Have we explored? We already know that age is what? V013, right? Or should we retain the actual number? V012. Let's retain the actual number. We should retain 13. Why? Let's retain V012. And then the other one, which is what? Marital status. Do we know? So if we don't know, what do we do? Look for it. Look for marital. If it doesn't bring it out, we go and look for something else again. Currency is here. Current marital status, V501. So that variable is of interest in our study. So we say also V501. That's for us to just generate our sample size. So sample size will retain only those who are unmarried as well as those who are between 15 and 24. Is it clear? So these are the two variables we will use to remove those people we don't want in our study. So first and foremost, what should we do for marital status? Let's tabulate that variable V501, right? Let's run it. Never in union, married living with partner, widowed, divorced, no longer living together or separated. Which one captures unmarried?
Never a union. Every other thing apart from
Apart from marriage.
I think a widow or no longer.
every other thing apart from marriage. Every other thing.
You know how we understand. See, this is where this is where you need to go and look at this definition. You look at the code manual, try to understand what is here. And if it does not directly capture what you are looking for, never in union, that is never married, that captures in some sense. So if you are going to be talking about this in your methodology, that's what you now say. You don't say just unmarried. Unmarried is defined as those who have never been in union. You get the idea? So you specify clearly. Exactly. So in this case now, let's just say our unmarried young girls that we are interested in are those ones who have never been in union, but they are having premarital sex. We need to see their parents. Why?
What will now ask you that? How do you tell somebody that is never in union to be having premarital sex?
Because they are pregnant.
If you don't have sex at home, it's when you are in union with somebody that you think about it.
No.
Union in this
You can have sex if you are in union.
Union is marriage.
Are you sure? Well, now there is like that. What is that?
No, union here is about marriage.
Union is marriage.
That's why you have to do that.
You have to
Because the thing is, you know, it's not just Nigeria. They are not doing this just in Nigeria. So they are considering context across different countries. You get. So for those now, let's now look for okay, let's use our code book. Like we have seen the variable now code book V501. Run it. It's telling you never in union is 0, right?
Yeah.
So now what do? Are you keeping or dropping? Either way, let's just keep. Keep if V501 equals what? 0. Do you see now? That equals is specifying that under this particular variable, go to where the code is 0. So it will still run. So if I keep this now, it has deleted 31,152. So let's run that variable and see what is there now. Never in union, only never in union is left. Can you see? So 10,699. We have not weighted it anyway. We'll do that when we are doing our analysis proper. So the next one now is to do what? Check what? V012. Tabulate V01. Where is it? V012.
But we're focusing on your group and just do the group.
We can use the group, we can use this. I just want us to follow some of the things that we did before so that you understand the process better. Of course, I could just use the group, but I could use this as well, such that I will just say, okay, let's recode, reminding ourselves of how to do the code. We've not anyway, it's too late to go back because I've already kept only this. V013 has been dropped. So in real you only have several variables here, so it's too late. So you have to do this unless
Is this the 7?
I'm doing 5,000 something.
no variables.
The variables.
Okay, I've run it again.
But let's just proceed, please.
I've run it, yeah, that's true. I've run it again from the beginning.
Okay, you can already do that again now.
Yes, when I did drop initially for that example, so I wrote it again. So now, to tabulate this, you can see it starts from 15 and ends at 49. So my focus is on 15 to 24. So those are the young women we are interested in. So let me say drop what? Drop if what? V012 is what?
Now we have to be careful.
It's greater than 25.
Is greater than 24. So if I drop this, only those ones 24 and below will be kept. So let's run this and see. So you can see we have between 15 and 24. We can keep this variable and then generate a new variable that is in group. So how do you do that? I'm intentionally taking you through this process. You do that by doing what? Recode. You recode this original variable. That's if you want to generate a new variable from the previous one. Or let's generate a new variable and call it generate age group equals nothing. Put nothing inside it, like I did the last time. Like this, generate a variable called age group like this, and then inside it put nothing, that dot, let it be empty.
And 8,000 plus
Missing the values, yes. So there is nothing inside it. All the variables, all the observations, the cases in that variable, they are 8,000 words, but they don't have any values. So this is what it's saying. If I tabulate that variable now, see, no observation. So there's nothing there. So what you need to do now, to now replace based on the numbers that we have kept. You know, we have from between 15 to 24. So based on those numbers, we want to label and keep value for this new variable called age group. How do you do that? You say replace age group equals 1. Depending on how you want to group code it, you can say 0, you can say 1, you can say, if for instance age group is your outcome variable and you want to do logistic regression, you are interested in those ones between 20 to 24. That means you label 1, you code 1, 0, 1, 1. Which one is 1? The one you are interested in, which is 20 to 24. So whenever I want to interpret based on using logistic regression,
15 to 24.
So 0 will be the other outside.
Outside
For logistic regression.
I said for logistic regression.
Okay.
If for instance this age is your outcome variable, and you know for logistic regression the outcome variable is dichotomized, where one is 0, the other is 1.
How can it be?
I'm just giving an example. The odds of being in age group 20 to 24. Can you do something on that? Just an example. It gives you the odds of being in this age group and all of that. So you say people with let me not say something ridiculous, but you get the idea. So when you now say you want to do that, that means your interest will be 1. The ones who are not interested will be 0. So those are the dichotomous nature of such. So I'm just giving an example. You can code it however you want. But for me, I would say replace age group equals 1 if V012, that's the number, the variable with numbers 15 to 24, is if V012 is greater than what? Or less,
How many groups are we going to?
or less than what? No. The first one now, 15 to, you know, we want to have 2 groups, 15 to 19, 20 to 24. This will be less than 20, right? 15 to 19.
Yes.
Are we together?
Yes, sir.
So if I run this, so if I tabulate that new variable that we have generated, so you can see. So those ones between 15 to 19 are 6,557. So I will now say again, replace this variable, the new variable, equals to if V012 is greater than what, or equal to 20, right?
Yes.
So if I run it and I tabulate, I'll get the 8,886. Madam, that 8,886, you can see it now. That's the total. So now we need to now label define. This is a long procedure, but I think it's important. By the time you move from this, you'll be able to use the shortcuts by yourself. But at least get this idea behind all these things. So the next thing I want to do is to label define. Lab define age. I can give you the same name as my age group. Age group equals, lab define age group such that 1 means 15 to 19 years and 2 equals what, 20 to 24 years. So if I run this, I've defined it. Then I need to now impose the new one on the age group. I will say lab label value age group. Can you see? So if I do that, it will still work. And if I now do this, you can see it has replaced it with 15 to 19 years and 20 to 24 years. That is that. So our sample size now, based on all we have done, is what?
8,886.
Is it correct? It is not exactly, because you have not weighted it to confirm the sample size. If there is a difference, you'll be able to determine that with weight. So you do the weighting with it, and if it comes out with the same, then you can confidently say, okay, now you're based on the weight. See the difference? 8,763. That's the actual sample size, not 8,886, because you have now used weight on it. So the weight now will give you that, okay, this is actually your sample size. Are we together?
What does the weight do to it?
It reduced it. It reduced the number. Instead of saying 8,886, it reduced it to 8,763.
We are already done generate with
From the beginning.
with SVY set.
No, that's SVY set. That is not what we are using. This is just a normal weight. SVY set is when we are going towards bivariable and multivariable level. We are working with models. You understand? Here we are only using the weight we generated, the importance weight, high weight. You can see. You understand? So if you generate it, you need to apply it. Application is where we are doing this. I don't know if you understand what I'm saying.
The generating of weight wasn't that what we're doing when we did gen weight equals
Yes.
0.05?
Yes.
So if you have done that, this thing needs to impose it. Okay.
You only generated it. You now take it and impose it on your analysis before you can represent the actual reality.
If you are attaching it to the variable,
Any analysis you want to do, you need to be putting the weight. You know we generated weight, right? So it's just a variable inside your data. If you look to the end of the data set, you should see something on weight. See, it's just part of the variable. So anytime you do analysis, you need to use it on your analysis so that it can be representative of a true situation. Now, so your sample size based on this Sample size, therefore, is 8,763. 3 what? Unmarried young women. It's because of you I'm doing this. You that you do not have laptop. Sorry, my laptop is not working. So the next one. Okay, you have done so you have identified on how to keep or drop and all of that, and how to apply the weights. So we have done all of this. Sorry?
The data set now.
Yes.
Was it only for females?
Yes, this data is just for female. We are using individual code data sets. That's for women. Women 15 to 49. Remember that initially it was 15 to 49. We dropped to just 15 to 24. There's a male code. There's another data set that's for men only.
This particular data set
is for women only. You have forgotten yesterday. Let me show you. We did that yesterday. Here. You see, birth record, data for all births to women, data for matched couple, household data that characterizes women of reproductive ages, data for under 5 children, and then men of reproductive age. That's male record. So we are only using the women data now. And why we are using the women data is because our study is on women, unmarried young women, right? So if the unit of analysis is on unmarried young men, we are coming to use male record. Are we together?
Yes, please.
I think we are almost done. We are fast. So we have done this. Choosing data sets for your study. We have talked about this just now. Choosing data sets for your study. Possible choices for adolescent studies. Just an example. We have talked about this. Data command if this and this. We have talked. You can use Boolean operators like and or depending on your work. And I think you all know the meaning of and or now. Do we? I think we didn't have to use and or in this one. What did we do? Marital status. Okay, we could have done keep if v.
We did that. V equals equal 1 or v equals 2 or.
Yes. I wanted to say something like this. When we were keeping like this, was it here? Where is that variable? I can't see it. Okay, for v0, keep if v0. Look at this here. You could have said keep if v501 equals 0, right? If those people are married and are unmarried, never in union. And then we just say, and the next one, which one did we keep again? And V012 is what? Greater than what?
No, that would be less than
24. We are keeping. Is less than
24.
Yes. Less than 25. You see now, we could have just done this. And then it will just keep all of those things without going through that stress. Just by using this and here. So it will keep those ones who are unmarried. It will also keep all observations of those who are below 25 years, which will be 15 to 24 years. So I'm just saying that you could follow this long procedure. You could just run this Of course, you need to identify the variables you are going to use to determine all of this first and foremost. So now let me just put it there. Alternatively, or the two variables or two indicators anyhow. Now,
That comment to have that drop.
hmm?
Why don't you take that comment? That the whole line, including the key,
To here?
the whole line, including the code itself, not just the comment.
To where?
So after drop, so after 78, so after line 78.
Okay.
Before we jump.
No, you know we did something here first. We dropped here.
That's
So
what I'm saying. So that was the alternative approach.
I think it should be. I think it should be here. It should be here. Okay. It should be here because we did this as well. Huh? This is for just one variable. This is for another variable. So let's just drop it here. It will give the same result. Now, the next thing we want to do, is it interesting today? Are we following better than yesterday?
Yes.
No, following, when I say following, I mean, are we getting it better than yesterday? Is it looking more, you are not
You
following?
understand because like a lot.
You have to understand, no? I'm talking to them.
No, I mean.
When I'm asking this type of question, I'm not talking to
I'm
you.
not answering your question. I'm saying that I can understand what they are going through.
You guys are supposed to be standing up and be telling them something. You are doing as if you are a student. So the next thing here, we'll talk about margin and appending later. Let's cover important things first. That one is very important, too important. So handling unique codes value in DHS data. For instance, missing values. Hello. Handling missing values. Are we together? In our data set, there are situations where some responses were not given. In some places, the responses are legitimate, that is, the missing are legitimate. In others, they are not. So, to better understand this, you need to read the code manual to know how these particular missing values are handled. Missing values such as dots, identified as the highest value in data. I think I mentioned this earlier today. Was it yesterday? Yesterday. The dot that you see is the highest value. So you should know how to work with it such that if you are, like the example I gave yesterday when I was decoding, I said from this value to maximum, you should be mindful of where those dots are, and you will know that by running your frequencies, or you explore it in your edit or browse window. You see the nature of the data. If you are seeing dots, you know these are missing values. But some of them are actually supposed to be missing, because, for instance, you could be asking a woman who has never been pregnant, how many children have you had? And she says 0, or she did not give any response. Where that value is not given, she's supposed to respond and say 0, right? Because she doesn't have any child. She has never been pregnant, but she's part of those sampled. So she has never had any child. So in that situation, 0 will be the correct answer when you are doing your V201. Or maybe she did not give a response, and that place is missing. So that not having a value is actually legitimate in the sense that she does not have any child. So that missing, you can replace it with 0, such that all those ones with 0 will be represented as those who have never had children. Do you know what I'm trying to explain? Yes. That there are some cases where the missing actually makes sense. And then you can replace them with 0 and it's still logical. But there are some areas that the missing, you don't expect any response, depending on the particular variable. So you need to understand how those variables are measured. And so missing, they are well coded in Stata and in DHS data. For instance, 98 now, they use it to represent don't know. Know whether to exclude from your analysis. This particular 98, you see in some data, in some variables, they will say they represent don't know. But don't know depends on your own interest. Do you want to talk about those who don't know in respect of your focus in your study? If you want to look at, for instance, what did she say now? What's that topic again? Unintended pregnancy. Now, somebody asked you a question about whether you've ever been pregnant or the last pregnancy was intended or not. You say don't know. And then some said yes, no. Was it intended or not? Yes, it was intended. No, it was not intended. I don't know. Are you interested in how those who don't know also? Are you interested in how their information will affect your outcome? So you need to be clear about your interest and how you think those things can be very important in your own study to decide whether you are going to include them or you remove them. Those kind of, and they coded with 98. So if you are doing the code as well, you should be careful. You need to know the codes represented in your variable so that you don't go and include some big values that will alter the direction of your work. So that's why it is important that you always do your descriptive of your variables. All your variables, look at how they look, the structure. The decision you are going to make will be in respect of your interest. And you'll be able to defend and tell why you have decided to go in that direction. I gave an example the last time in Lagos about when you're using Likert scale, ranges from strongly disagree, neutral or whatever, and then you have strong agree and strongly agree. 5-point Likert scale. And then you code it strongly disagree as 1, disagree as 2, neutral or undecided as 3. Then you have agree as 4, and strongly agree as 5. Have you seen Likert scale before? 5 points, and then you code them that way. At the end of the day, you want to measure your construct, and then you are giving those who are undecided. Between those who disagree and those who gave information to you as being undecided, which information do you think is more relevant to you? Between those who said I disagree and those who say I'm undecided. Disagree is more important to you than those who say you don't know where they fall, but you give them 3. Even value higher than those who gave you meaningful information. So you need to know how you handle some of those things. I always advise people that undecided is that you remove it completely. So you'll be able to know. I mean, so you are the one that will now, based on your interest and your focus, how you want, you'll be able to come out and defend whatever it is you have done. So that's okay.
For some believe that you can still make use of the people that are access to contracts. It depends on what you are doing. Sometimes, for example, you want to design something like an international study. You want to find out, do you think net is useful to prevent malaria? The person says,
Please sit down.
Completely disagree. I disagree. That one. Somebody that say neutral is 0. The person that say I agree is 4. Is that the perspective that you
See, that makes sense.
So if you now say neutral, for the person that you pick as when you look at intervention, it's easier for you when you look at the proportion that fall on the neutral. When you are designing your intervention, you know the people you want to buy over to the agreement side. So it depends on what you are doing and the nature of your study to know whether you are going to remove them or you want to just say yes or no. And that's why some people say, is either you say yes or no, not I don't know. Or sometimes you put some question, people say I don't know. You say, is it yes or is it no? So you rather just put them on the negative.
Thank you.
I also think in GHS, if, for example, in what you just described now, if the difference is actually or I don't know, is actually a variable, it will be coded differently, not as a missing value.
That's why I'm saying here, it's coded as 98.
Exactly, that one is not,
it's not actually a specific code as a normal code for other options. So if they code it as extreme as possible, so you know it's different. Yes, sir? Okay. So thank you for that. I agree because, of course, as you said, it's intervention based and it's actually meaningful to do that. But my own argument is when you are, because at that level, that is descriptive level. You get what I'm saying? So you just be able to identify them and say, okay, these are the people who are undecided. You can locate them. But when you are scoring them, they shouldn't have bigger value than those who are actually contributing meaningfully to the yeah. Thank you for that. It still depends. Anyway, the bottom line is have sufficient justification for what you do. And you get some justification from where? Literature. That's it. So because I'm saying so because of some of the people I've worked with and I noticed some trends just based on my experience and what we have seen in literature. So now, nice. Now those are specific type of missing values as well. So you understand when you want to use a particular variable, when you have kept your variables that you are interested in, you look at them individually, you explore them and see where you probably have missing values and how you want to address them. Some missing values are realistic and logical, so you cannot just toy with them, while some you may need to just drop them because they may be interfering with your model at the end of it if you are doing if you are modeling. I'm trying to finish as soon as possible, but I believe that as I'm going, this pace is not affecting the need for us to gain. I mean, we are gaining from what we are doing, right? Like if you sit in your corner, you should be able to explore for as long as possible and then do all of these things that we have done, right? You'll be able to extract your sample size by yourself, right? Thank you.
Break in about 8 minutes, so that fellows can have a look at their work before we leave here.
It's just one slide after this. After this is just one more slide and that's it. But it's
your work. Because we realized that overnight you came with something very little. So we're going to sit here.
There's internet.
You relax.
We actually have internet, sir. I'm using MTN.
Azan,
sir.
I don't know what's wrong with yours.
I'm using MTN, sir. No, I'm just saying that even if I go.
He's trying to justify why we need to handle.
Sir.
And that's why the next stage is just to be romancing your data.
Sir.
You don't want to romance your data.
Are you on? Yes, in a meeting one.
He's tired himself. He wants to.
We have a meeting today now. Abi? No, we have one today. Okay.
Our meeting is finished. I've even sent a reminder.
No, not that one. Sir, we have a meeting today. The Yora project.
When is that?
This evening, like 7.
7.
Yes. And I need to go and prepare. My M10 works fine, don't worry, sir.
Once you are done, how many slides more?
Just one after this. And what we want to do now from here is just to do the analysis, and I'm sure it's not.
I don't want a situation where we'll come back again tomorrow and we're just where we are, because after tomorrow.
No, I'm just talking for myself, sir.
So the fellows can relax,
Yes.
all the time.
Yes.
There's a session, fellows works session. So you can sit down, you can think around here. But if you think the comfort of your room,
No, they don't have
sleep here or to be close.
They don't have MTA, sir. Don't worry. I'm the only one. I'm the only one using MTA.
Mo ti ṣe fún àbí mo ti dẹ́kun bẹ́ẹ̀ yẹn ṣe mo wá.
For me. Okay. So now let's go to DHS analysis using SCAPA. Analysis of frequency.
How many number of message samples you render data set?
No, I don't think there is a specific number. By the time there are some situations where maybe because of missing values, you'll be seeing confidence intervals very huge. The gap you'll be seeing between one interval and the next when you do your models. You'll be seeing maybe when you run and then you see the estimates, then check the confidence interval, you'll be seeing gaps and all of that. Some will not even present the result because of the huge level of missing value. So it depends. So by the time you do your analysis and you see the structure, so it's also always better to just address those missing values before you go there.
You can. I think sometimes you not able to address the company.
No, you make a decision on how you want to address it.
You have to.
Yes. Yes. Those missing values, like you could be having, for instance, some people, I don't think we saw that anyway in that children ever born. For those, for instance, if for instance in the children ever born, you do the frequency, and then you are seeing those who have zero number of children to 17 at the maximum. Maybe some people did not review their own. So for those who did not respond, maybe they now put 98. No, the values are numbers. So now that 98 also is the number. So you will need to decide and say, okay, you are removing, it makes sense, a lot of sense to remove that 98 because it will be interfering. The system will see that as just ordinary number as well as the number of children.
Okay,
So
what I'm saying that it's better
to remove that in that situation.
You are feeling it.
No, now you are feeling it for them. No, I said change some dots to zero in some cases. So you need to understand, that's the bottom line, understand the missing values and how to address them. I'm not saying you manipulate your data. You understand? When you run your analysis and you see that it's different from the report, you know that what I can do is back you. Then you can trace your steps. Analysis using frequency distribution, I think we have done that. Usually your descriptives, you do frequency distribution, age group, education, place of residence and all of that. Descriptive using tab start. Descriptive using tab start is when you are dealing with numeric. Let's do an example of that. Tab start. And it's true. Say tabulate V, let's say age group, and you have your glasses on now. How about now? Is it better? Tabulate, which other variable did we? When you have categorical variables, what do you do? What are you likely to do? Describe the categories. V024, tabulate V025. Look at these are just descriptive analysis. descriptive or as univariable. When you run all of this, I'm going to be seeing your, when you run this, you'll be seeing all of your frequencies and percentages. But there's a code that you can use to run everything at once. It's called tab 1. Are you with me? When you do tab 1, instead of running them one after the other, you can just say tab 1 and then run everything at once. It will run everything at once. Is it clear? You have been doing this one? When did you start? Okay, clear, very good. So it's not new. Now, tab start is used to work on numeric variables that you look at other description of that variable, maybe using the summaries. You can do tab start. You want to see the statistics of a particular variable, let's say, and it must be numeric V201. If you run this, it gives you the mean alone. But you can do option and say, I need the summary of, you can do mean, you can do standard deviation, you can do, let me see, help, tab start. I don't have all of this is offhand, so if I go to help, I can learn it. So you say options, see the statistics. You can do mean, count, sum, maximum, minimum, and so on. Is it clear? These are ways you can actually explore further regarding using use of tab start. You can do minimum, maximum, and so on. So if I run this, see it will give you all the possible ones you have specified in your statistics. So if I want to do more than one as well, V201, which other one is continuous there? Or count. In the variables we have kept, key V005. Okay, I think for years too, we have V0, yes. V012. That's what I wanted to remember. So you can do for 2. It will show for V201, V012. So this is for age group, and this is for. So if you have more variables like that, you can just include, and it will run everything and show you. That is for use of tab start. Have you done this before too? Okay. So the next one. Estimating prevalence proportion using tab command. We have done this. This is just running frequencies and percentages as well. You know, all those percentages are prevalence. When you say proportion, of course, you have identified your denominator, you have reduced to your sample size. Once you run it, you get, okay, this is the proportion of those who are using contraceptive, this is the proportion of those who are married, and so on. So we have done that. Now let's go to bivariate analysis. I think we're almost there. Bivariable analysis. You know that all of this thing we did not wait. I'm not even sure. We'll wait to work with this. Because you have to always wait your. Let me see. Yes. So that's weighted. Let me see. Option weight is not allowed here. So that's one of the challenge you might face. So for you to use weight here, you have to do it one after the other. So let me just control that. Now, bivariate analysis. Bivariate analysis can be when no specific outcome variable is specified. A good example is correlation, right? But if a dependent variable is specified, we know which one is dependent, which one is independent. We are talking about bivariable analysis. That could be a simple linear regression. Bivariate analysis is also chi-square, when you are not specifying the exact outcome of interest. You are just looking at the relationship and the association. Okay, what is happening between this when this is this? All of these things are not casted in stone. You can. I remember there was a time we were doing theory. Any sociologists here? We were doing something on theory, and I used to wonder how people are able to determine certain things in using theories. And theories they have at micro level, macro level, meso level, and
That's just one theory.
that's just one theory. Huh?
That's the sociological theory.
Sociological theory. Socio-ecological theory. I thought they broke down theories to those levels, that theories apply at different levels. Don't distort my head though.
That theory you are talking about is just one.
That is not a theory. Okay, that kind of structure is a theory.
It's just a theory. It has wide application.
Okay, where I'm driving at is this. I'll go and read more on that thing and get what you're saying. Where I'm driving at is this. Like, when you want to talk about design studies, I remember going to my supervisor and explaining that, how do I determine which type of design I'm using? And then he was like, it's not, you use your imagination to look at the nature of what you are doing. It's not like you want to go and look for one design elsewhere. Okay, a design can be explanatory. When we are talking about theory, when we are trying to explain an event based on some other variables, that is an explanatory kind of relationship we are trying to do. And then if your design is cross-sectional, you can combine the two and say it's a cross-sectional explanatory design. I was like, so is that how we do all this thing? So it's based on what you are doing. So what I'm driving at is that this is not cast in stone. So based on what you are doing, you'll be able to understand, okay, this is what this is. This is what this is. This is what that is. You get what I'm trying to say? So saying bivariable, bivariate, and all of that is you two understanding what it means. That's it. So when I say bivariable analysis, in this case now I'll be looking at some a situation where I'm looking at the relationship between two variables, where one is actually an outcome and one is the explanatory variable. Give me an example. Here we'll be looking at, let me see, maybe there's an example here for chi-square. See, chi-square test using tab command without survey set. This is without applying survey set, without saying we are dealing with that analysis in respect of the survey we declared earlier. And then the second one is chi-square using tab command with survey set, explaining to Stata that we are using a survey data. Let's do an example. I remember VC once said that, recently, that one of the things that we need to focus on or understand before doing analysis or in your research generally is to be able to ask questions first and foremost. Of course, research itself starts with identifying a problem. You need to know, you ask questions regarding that problem. Why is this problem like this? So you have asked the question you want to answer. But the way you structure the question should be measurable. It should be smart, so that the objective will be smart. You know what I mean by smart? Some people don't know. Specific, measurable, achievable, realistic, and time-bound. Yes, so it should be smart. All of those the object should be characterized by those attributes. So you now said after identifying that, you want to know whether you are comparing one to another. When you are comparing something to one thing, You want to know whether you are comparing a known value to a new value, or you want to know. So you need to know all of those before you set out. So then from there, understanding how you attack that thing, you now go to the analysis proper based on your understanding. So we have understood here, for instance, that you want to do a bivariable analysis, and I'm asking you for example. There's one outcome, there's one explanatory variable, and they are both categorical. But we are not comparing one to another. We are just looking for association between them.
Can you use chi-square as well?
Yes. So let's use chi-square and give me an example. That's what I'm asking. Give me an example of that.
Contraceptive use.
Is it part of our variable here?
Because we should be working with the variable.
Because we have already dropped. We can actually go back and remove and all of that, but let's focus on based on this. These are the variables we are interested in here.
Unintended pregnancy.
So unintended pregnancy.
Yes,
No, let's look at this. We are not looking at unintended pregnancy now because we did not save the variable for wantedness of pregnancy. So we only have for region. Let's look at the relationship between adolescent age category. Adolescent age category. I don't want us to go too far. Let's focus on the ones we have.
we have variables.
Okay, let's look for okay.
You go for your life. Go for
wanted pregnancy.
We stand.
How do you know I can't see it? How do you know I can't see it? Wanted pregnancy when became pregnant.
yes, these are for the 6 children. For the last 6 births.
Then later no more. So let's focus on the first child here. So wanted pregnancy when became pregnant. Yes, I wanted it then. But I wanted it later. Imagine. See, they all mistimed. It's too small. Let's look. I don't want us to add this. Let's look for a variable that. Well, I think there is M0110. To look at age group and place of residence. Tab. Before, we usually used to use 2, put 2 here, but later they upgraded theta. We didn't use to, we stopped putting 2. So we have V024 V, or let's say age group. I don't want the big ones. Let's use 25. I don't want to stress myself at all. So this, what is the difference between this and this?
interchange the row and column.
Yes, what's the difference between this and this? So you can see the frequencies. For years here, for type of place of residence here. How do you interpret it? So what determines what is row? What determines what is column? I think independent variable should always be where? And the dependent should always be. So now, what I will now ask is, because these are frequencies, let me now include row and column. Now, what's the difference between these two? First one is row total, because if you look at the years here, you see that the total is 100 here. Row total here is column total. What's the difference between the two? How do you know which is correct? Which one should you choose? I should tell you. Exactly. It depends on what you are after. If I'm saying I want to look at the effects or the association between age group and type of place of residence, does my age influence where I will be staying? Now, if you look at it in terms of 15 to year, in terms of row now, focusing on the row, the interpretation of this will say, among those who are 15 to 19 years, 47% are urban residents, while 53% are rural residents. And then I go to 20-24 years as well, and I say 58% are urban residents and 42% are rural residents. Does that explain the interaction of age, implication of age on where I'm staying?
Yes. Explain.
Yes. Does age explain where I'm staying like that? Does he give an idea of the association?
The residents. The likelihood of where you stay.
What I'm driving at is this. My interest now is not focusing on age any longer. It's not focusing on the implication of age on where I'm staying. Because I'm looking at age, one age. the proportion of those who are here, they are 78%, and here is 22%. This place is talking about the proportion regarding this age that I'm interested in, how they fare regarding urban and this. I don't know if you get what I'm saying. What I'm saying in essence is that your interpretation, your analysis first and foremost should be based on your interests, and your interpretation should guide what you will decide to do, whether you want to use row total or column total. You get what I'm saying? You get it. There's no way you don't get it. You get it. So this is without the weight. So to now declare a survey that you should look at it in terms of the survey set that we set earlier. So we'll do this. It will give you the frequencies for column as well as for row. But in this case, it will give you in units. So if you multiply it by 100, you get your actual proportions. Are you with me? So here now, this one is not giving you the units. The unit here you will get from here. That's what we do. We just duplicate it. So you run the one for frequencies, and then you run the one for the survey. Not allowed. Wait. We use okay, it does not support this high weight. However, the proportion that you are going to be interpreting is this. You use the frequencies from here, and then you use the tabulation regarding the survey here, and then you multiply the output by 100. That's how you get your frequency. For this one now, for 15 to 19 years, you multiply this. This is 54%. This is 65%. This is 46%, and this is 35%. So weighted and unweighted cross tabulation.
So this SUI
is for the weight regarding the survey. This is how you weight when you are doing the cross tabulation. You know, when you are doing the weight for descriptive frequencies and percentages, you just put the value of your generated weight in front.
So you just add weight, just like you do directly.
Yes.
But
this one is you use the survey set weight that we declared. So it's also the same thing that you use when you get to multivariable level. So where are we? See, I said I thought I was almost done then. So the next one is independent t-tests. By group. You know, when you read the notes that was given to you the last time, was it yesterday? How you select your sample, how you select your analysis technique. When do you use t-test, independent t-test, for instance? The basic assumption, you have a continuous dependent variable, and then you have a two category independent, not at most two. And you say at most. Okay, at most two. Wait, which one is at most two? Just two. Which one is maximum of two? Just say it's two. Like, if it is one, do you want to compare one with what? That's one what's it called now? Is it one sample comparison? That's where you now compare the value within that sample against a known value. The independent sample t-test is comparing two groups. Okay? In respect of a dependent variable, for instance, which one do we have here? Number of children, right? Children ever born. Thank God we saved that. We were smart though. So now, t-test, an example has been given there. So to do independent t-test, we have identified the basic, we have satisfied the basic assumption, right? The basic assumption, right? Another assumption is what? Most of those parametric normality assumption, that the outcome is normally distributed. How do you do that? Let's see. V201. Let me see if it will plot. Eh? Let me see if it. See the histogram. And most of them are 0. This is not normally distributed. You know, the challenge you have here is because you only have between 0 and 17, and most of them most of them have any child, 0, right? And because they are adolescents, they are very young, so they don't have children. So in a way, you have that issue. And when you have such, what is the alternative to using t-test, independent t-test? The non-parametric equivalent for t-test, for independent t-test. With me. Is that so? I know you know. You are very good. So that's the equivalence for it, with me. So, but don't worry, we are not, when you are doing your own, make sure you do all of that. But for now, I want us to do independent test. So let's just see and see if we did not see that thing was not normally distributed. You should be seeing it though. I'm just saying, now, you can be blind now. T-tests, yeah, that's for the Instagram to test the distribution. If it's normally distributed, when you plot it, you know it should be in a bell shape. But here, it's like, is it bell or? Huh? And there are statistical approach we can use.
Because most of the time, this kind of survey, it's already subsumed. Like normality assumption is good for this kind of survey data.
Who says so? Who says so?
I'm speaking from this point of view because you are dealing with human behavior, which is like it has a lot of heterogeneity. You are not expected to most of the time actually consistently have a bell shape.
Where did you get that? let me explain to you the idea behind normality. In fact, it is mostly applicable with humans. You rarely see people at the two extremes. Most people are usually in the middle. You understand? Talk about students in the class. Only few will get A's, only few will fail. Most of them will be in the middle. So when you plot, they are usually like that.
I think that's it. What I say?
I'll say that we do normality in certain analysis for us, because with big sample size and with
No. See the idea of big sample size. You can relax it. And the reason is because I think I explained it. Was it here that I explained it? The larger your sample size, the more representative your analysis will be. if we can go to all our population, we don't need to be selecting sample. So the bigger you go in terms of your sample size, the more your analysis results will come. So even if sometimes you don't meet some assumptions, you can still go out because the sample size is large enough. Do you understand? But to say you are waving because it's humans. No.
Like with big sample size, the normality can be that. I was saying in some cases that we wave normality.
No, that's not what she's saying.
That's what I just said.
With this DHS data, you are more likely to do what?
To have a normal distribution.
Is that what you are saying?
Wave normality because it's large.
Is it the same thing?
Really? No, it's not the same thing.
So I'm trying to let her know that it's not what she's saying that she's also saying. And also, if you say with this DHS data, it doesn't mean that every unit of analysis that you're going to work with will be normally distributed. It depends on what you are focusing on. What if your sample size based on your interest, when it is small? So, you know, so not say because it's DHS, then, no, you don't need. Exactly, something like that. If you break it down like that, you know that it's very small. It will not really.
These are the kind of economic assumptions that are affecting our.
Actually, to a large extent, I've read a number of economics textbooks. I think I did some economics. And one of the arguments I saw, I can't even remember the title of that book again. One, Amartya Sen. You know,
It sounds familiar.
Amartya Sen. I read that book. That one lecture I wanted to frustrate. I went and bought. I read that book very well. That man was talking about how the way we apply theories, it must be. That was why I picked the word eclectic. That we need to consider the context where we are applying some of these things and how well those theories will be represented in that context. That's those are the arguments I was not giving in one of my exams. Like when you without considering. I did what? What did you say? No, it was no, not argue. I said I argued when I was writing. You know, some of those points I still remember because I read that book like some. I still remember the name itself is crazy. I can't believe I remember it. So we need to consider the context and how well those theories can be applicable to our own because of where they are being developed. But here you don't see people saying nonsense and hey, do this and do that as if it is yes. Anyway, that's by the way. I think now there are people who are actually arguing and saying something. Which one? Which code?
Like notes, attach a note.
Okay. You are assuming that we share this, sir. Okay. Applying survey sets to cross tabulation. Yes. Thank you for reminding me. I'm going sure I need to go. So we are done with chi-square. No, we have not done chi-square. So in front of this, to show that what we have done here, for instance, without chi-square is descriptive. It's just purely descriptive. We're just describing the distribution of one thing to another. What we now apply statistical implication is by applying the chi-square test, and it's chi2. Yeah. So if it is row you are dealing with, you use that, and if it is column, you also put it here. What is it again? Chi-square not okay. It's because of the survey set that we have added there. So if you use that here, so this will show you the chi-square test for either row or column, and the chi-square test here is showing PR. That is the probability value, which is the p-value for chi-square, and this is chi-square value. So you'll be able to determine whether the relationship or the association you are establishing is statistically significant or not. As it is it significant? Yes. Because at 95% confidence and a 5% level of significance. So because it is less than 0.05. I'm not supposed to be explaining this now. We are doctors.
Make it an holistic explanation.
If you don't know it before, this is what I used to remind myself. There was time I was presenting in one of our seminars. I forgot. One of my lecturers said, I'm not about certificate. So when I was reading at some point, I came across this. So if the p-value is low, the null hypothesis must go. If the p-value is low, the null hypothesis must go. The null hypothesis is a hypothesis of negation, which is always saying there is no difference. So if your p-value that you have calculated is lower than the tabulated, which is the 5%, then you will not say there is no significance, then that null hypothesis will go. There is. That's the alternative. So you can use that too, so that they don't collect your certificate back home. So now, t-test. The t-test now, like we have said, across, let's just look at the age group. By which group? Age group. Independent t-test. This is the t-test value. Here you see hypothesis difference is less than 0. Hypothesis here difference is equals or is not equal to 0, and here greater than 0. These are the three directions that we talked about. It could be less than, it could be greater than, it could be not equal to 0. If it is not equal to 0, what does it mean? There's a difference. Is that not it?
Significantly different from 0, depending on the probability.
No, I'm talking in respect of the different hypotheses here. These are hypotheses that we could have formulated in respect of this analysis. One is less than 0, one is not equal to 0, and one is greater than 0. But we are not looking at direction now, whether it is less or greater. We are looking at no difference. The hypothesis we are going to have is that there is no difference between age group 15 to 24 and 15 to 19 and 20 to 24 in respect of children ever born. That's the null hypothesis, right? And there is no difference in children ever born between those age groups. Now, if you say there is no difference, what does it mean? That it is equal to 0. Is that not it? Yes. So if you also say it is not equal to 0, that is the alternative. Is that not it? So focusing on the one that is talking about the not or equal to, which is way in the middle. What is the probability value? Which is 0. What? 0000. What does that tell you? It is statistically what? Because when the null hypothesis, when the p-value is what? Low, the null hypothesis must go. Don't forget to, and look at it. Your t value is minus 20.4. Your degrees of freedom is 8,884. The null hypothesis is difference equals 0. Can you see? Difference equals 0. What does that mean? There is no difference. Is that not it? Yes. So between age group 15 to 24 years, 15 to 19 years and 20 to 24 years, there is no significant difference in what? In the children ever born. That is the null hypothesis. So the report now from our result, where the p-value is less than 0.05, then that means what? You reject the null hypothesis. If you reject a correct hypothesis, a correct null hypothesis, what error have you committed? Type 1. So if you accept or fail to reject a wrong hypothesis, null hypothesis, what have you done? What type of error? Type 2 error.
Why do statisticians prefer fail to reject that?
Yeah, because
I don't like the word fail.
people actually I have made inquiries, and I think it actually makes sense to say fail to reject, in the sense that we are not proving anything. When you say p-value, what is p-value? The probability that we are assuming that the null hypothesis is true, which is that there is no difference between the groups. Now, when we do our analysis, the result is showing that there is a difference. It is the null hypothesis we are talking about. We are not talking about the alternative. And what would the result here, what is the result saying? It's saying that the probability of getting this t value or a value bigger than this, we are not saying we want to go and accept something different. It's just the probability of getting this t value or something bigger. When we consider the null hypothesis that it is true, is this. It is a probability. I don't know if you understand what I'm trying to say. We are not actually looking to talk about alternative. Our interest is not on the alternative. So if you are saying, okay, you accept the alternative, it is not really the alternative that is of interest. So it is that we reject this or we fail to reject it.
Because we actually didn't analyze for alternative.
Exactly. So what is me too, I used to, but I had to do some still, I'm sure it's still not clear to some people. Just continue to explore and read more about probability, p-value. So some people are even saying that p-value is not really good enough for making decisions these days any longer. That confidence interval is much more important than the p-value. By the time you read more, yeah, they are related, but if you, of course, the decision is very almost the same. But that gives you an idea in terms of the magnitude of the difference between the intervals is stronger than the p-value. Well, depending on where you fall, there are different schools of thought. So let's continue.
Let me say something here. When we talk about confidence interval, if you look at these two heads, the closer they are, it's just like you have two. The way they are standing, it will be difficult for her to pass through. Now, can you move a bit further? It will be easier for twice of her to go through. The larger the confidence interval, the more error you introduce.
Exactly.
So when we talk about p-value, I'm not trying to argue for or against.
Okay, sir.
Because to me, I don't see any difference. When we talk about p-value, what we're saying is that I'm not willing to make more than so percentage of error. Okay? And so, if I'm rejecting a particular hypothesis, what I'm saying is that I am 95% sure of what I'm doing. If I miss it at all, not more than 5%. So the moment you increase your confidence interval, for example, if you are looking at 10%, that means 90 confidence interval. If you are looking at 20%, that means 80. So you have more errors introduced into that thing. Anything can come in. Now let me ask you this question. If you are rejecting a particular hypothesis at 5%, are you likely to reject at 1%?
5%, right? 1%.
1% is
99. No, it's stricter.
If you are rejecting at 5%, are you likely to reject at 1%?
depends on what.
You are not rejecting at 1%.
Why?
You are not rejecting at 10% rather.
You are more likely.
You are more likely actually.
If you are rejecting an hypothesis at 1%, will you reject it at 5%?
No.
Why?
Because the chance of error is.
That is exactly, that's the picture. That's the picture.
Thank you very much, sir. That's good. Thank you very much, sir. That's how, see, you can't fight it. Thank you very much, sir. So let's quickly rush. Okay, I think I'll just do. We have done the t-test now. Correlation analysis, ANOVA, binary logistic regression. Those are the things we want to do, and then we'll end it. Correlation analysis. See the context. Boy.
The t-test, you don't need to wait it now.
The t-test. I've never weighted it before. Let me see. Let's see if it will work.
If it has any effect on you,
there's no punishment for trying now. If it doesn't work, then it's not working for it. Did you work in your own? See, option is not allowed.
okay.
It's just that you are most likely, when you are doing all this bivariable and multivariable, you are most likely going to get the same outcome if you don't have too many missing values that will distort your result. You can see that the differences you are saying, they are not really much, but in some cases they are important. So if you can actually ensure that you represent reality, do it. So where it is applicable, you apply the weight. What if we use survey? Will survey work for it? This test is not supported by SVI, so that one does not work for it. So correlation analysis correlate age group, no, I said age group, V201 and what? V012. Detail. What do we use to? Is this summary? Is this summary that we use? No. Correlate. See, that's how it works. If you can't remember, what are the possible options? Variable list. The correlation options. You have observation, significant value. Here you can ask to show significant value. You can also ask to show means. So if I say, if you are working on your own and you are finding it difficult to understand this, just do help. Put the command there. You go there and read. You'll be able to guide yourself. So you say, correlates. I'm trying to see children ever born and age. To correlate them. They are both continuous or discrete, as you may call it. And then you have, what are the options? Mean and what? Significant value. Did it work in your own? What did he say to me the other time? Sig.
Not just S.
Not just S. I've become lazy, that's why. No, I'm not lazy, I'm just tired. Because I like showing distribution of means. If you are trying to say Is there any significant difference between something and something? Oh, this is correlation. It's not independent t-test. Let me just run this. Let's read it again. There's something missing. The options for correlation. Here, you have means M. Okay, significant is not there. It's pairwise correlation option that you have significant. So, mean will work here first and foremost. Let's try it. So, the correlation here is showing, these are the observations. The mean for each of them, average, like we saw the other time, standard deviation, minimum and maximum. And then this is the correlation between the two. There is no significant value displayed. But you can see, from what we learned yesterday, 0.22 is the correlation between children ever born and age of mothers, between 15 to 24. What does this mean?
They don't have correlation.
Huh? They don't have.
No.
It's weak. It's not like they don't have. They have. So if we do pairwise score,
But we're not saying the significant.
that's why I want to use the pairwise score. And then there's something missing. So this is the significance under it. 0.000, so that's less than. It's not like that thing is zero. I hope you know. It's just that it is so small that you cannot see the other values. So let me just put that here. So in case you want to use that to find the significance as well. So the next one, what did I say this next one will be? ANOVA, analysis of variance. You remember that your group, your explanatory variable should be what? Should be what? At least, you like this at least very even you two, you are laughing. You know I will say something. At least 3. The explanatory variable should have at least 3 categories. And the dependent variable should be continuous, discrete, anyhow. So what you want to do is to put your, what's the command? You do one way, because we are dealing with just one explanatory variable. If there are 2, what do? 2 way, right? Is that not it? So you look for the command to do that. So one way, what's the variable we want to use? V201, children ever born, and what? Which other one? Region. V02, is it 4 or 5? I think it's 4. If I run this, you can see this is the ANOVA result for this. And I think this should also have means. Should be able to have means for this. To give you the average children ever born per group. Let me see. You should accept it. See the means. See, you know that I did not know whether it will accept or not. But I said it should. There are some things that you look at and you think it's supposed to work. And once you put it and you try, it works. Good. Go ahead. You have the mean average number of children ever born across each of the region. And then you have the ANOVA results also. Because you can't be saying there's a significant difference in the means of at least 1 or 2, 2 or 3 of these categories, and people cannot see the means you're actually talking about. So you need to do a descriptive of that and show, okay, these are the means and then this is the significant, this is the difference, the influence of this, the statistical implication of this on children ever born. So as you can see, the probability value is what? What's the probability value? Huh? Are we, look at this, are we picking this or this? Huh? The one in the table, thank you. That is actually the one for the test. This is Bartlett's test for equal variance. When you say the variances are equal, what does it mean? Equal variances. Huh? Go and find out. So this p-value, is it significant or not? That means across these means, the difference you are observing are statistically significant. Where is the significance coming from? That's another thing. You do post hoc tests to find out where exactly the difference lies. So one of the options you can use, there are a number of them. There is Turkey. Is it Turkey or Turkey? So there are a number of them. So you do post hoc test and that's to establish where exactly 456. That's to establish where the difference lies. So the next one is I've done another. Okay, let's do multiple regression analysis or maybe simple linear but I think you can do all of those ones now. Let's just do logistic. I think we coded. Did we code anything? Huh? I'm tired too now. So let's do logistic regression analysis. There was a time I was reading literature. Every work I was reading was logistic regression analysis. It's like there's no other test again.
You people are managing this first food teacher.
So
he wants to make sure he finishes this thing.
But they are getting it. They are getting it. They are actually following. That's why I have the confidence that I can actually leave. I can leave now and they will do the rest.
Asan, they are not just protesting overtly. They are protesting subtly.
So this is what is left, sir. Remember, when you use, there was a time we talked about. For a good teacher. Yes, sir.
If your student cannot reproduce what you have taught, you are a very bad teacher.
Sir, if you test them now, nobody will score less than 8.
No, you just know how to start. It's too easy. The moment you learn, you're still likely to remember 90% after 48 hours. You know how it drops.
That's why
wait for them till tomorrow.
That's why I
want them to just bring this last one want to do.
That's why I like to do immediate post-intervention test.
Okay, that's how you want to do it.
Immediate post-intervention. We will let it go for 6 months so that they will know that we did something. Immediate post-intervention. So after this, you go and do it, and so you keep it. By the time they ask for question, you now be bringing it out. You understand? Now let's move to the last one, logistic regression. When do you use logistic regression? This is the assumption. The dependent variable must be what? Dichotomous, and your focus of, your interest there should be coded what? 1, right? The categorical variable that is dichotomous, that you have coded as binary. One is 0 and the other one is 1. That means that 1 is the one of focus, of interest, right? If I'm looking at practice, those who are not practicing, those who are practicing. Practicing is my interest, so I code that as 1 and the others as 0. In this case now, I want to, which variable do we have that we can use? Children ever born? Have we coded it? No. Let's just record V201. Wait, jokes apart though, we are getting what I'm doing, right?
Yes. It's a jokes apart too.
No, it sounds like maybe I can't be standing here. You say you don't know now. That's why I'm trying to carry everybody along. I'm even speaking to issues that don't concern what I'm doing so that you can remember. So please. So now record this such that 0 equal if 0 equals 0, no child, and 1 to 17 equals 1. What should I say? At least you're supposed to tell me this. At least a child. So you generate ever giving birth. Let me write it. Ever giving birth. Did you get how I recorded this? Record children ever born such that those who have 0 child, they are equal to 0. Record it as 0. Name it no child. And those who have between 1 to 17 children, code it as what? 1. And name it what? At least a child. Then generate ever giving birth. Converted from discrete to dichotomous. Just because we want to do logistic regression. That's why. So let's tabulate and see what is there. See, no child, at least a child. My interest is on those who have at least a. Yes, it's correct, right? Because I saw 402, I'm like, how come? Then I remember that we are dealing with people between 15 and. So now, to do logistic regression, do logistic. What is the outcome variable? Ever giving birth?
Yes.
Huh? What did you say? Ever giving birth is the outcome first, and then let's see how place of residence will influence that 025. Maybe region too. 024. What else do we have there? Age of mothers, right? Age group. Because all of these, they are categorical variables. We need to specify that they are categorical variables, and we do that by doing what? Putting I dot. We domarize it. That's how we do that. Domarize is to say whether it is, you say, when we are looking at, in multiple regression analysis, all the variables are continuous, right? Multiple. The outcome is continuous, the independent variables are continuous. Multiple linear regression, yes. So, thank you, sir. So, if you want to do the analysis, interpret in that respect, it is just one variable that you have, and it is continuous. There are no categories. But the idea here, using I dot, is to separate each category and look at it one after the other, as if they are one variable, like that of multiple regression analysis, multiple linear regression analysis. Do you know what I'm saying? Dommarizing is using I dot is just to look at the categories one after the other. You get? So what we now do is to compare at the end of the day the categories to a particular reference category. Let me run the analysis, you see what I'm saying. If I run this now, logistic regression, and this is the result. in odds ratio. Alternative to using logistic is probit. Let's just put that there too. But that's not where I'm going yet. I'm coming back. Well, we are done. Probit. So if they say, have you used logistic before? Have you used probit before? Just, but probit will give you a result in coefficient. It's not in odd ratio. But when you exponentiate coefficient, you get odd ratio. All these, each of these values now, if you exponentiate them, you get the odd ratio equivalent.
You can get the margins.
Sorry?
You can get the margins too.
You can get the margins too. Our economics is. So what I want to do now to explain this. And also I think if you put this here and you give option of odd ratio, let's see if it will run without probit. Say odd ratio not allowed. Okay. But there are some situations that you give options and it will work. It will give you your result, your estimate in odd ratio. So now let's interpret our results. You can see that we don't have any survey here. We have not applied any survey here. So let's apply survey so that we can do that once and for all. Let's not waste our time. Time is fast spent already. Survey. Let's see if there are differences there. Clearly there are. We have 1.98, 1.900. Can you see the difference? The difference in applying survey, that is the survey weight, and not applying. Let's see, how about the significance? See, the distribution here. This northwest, northeast, south-south, and the first one, northeast, they are all significant in the unweighted one. Now look at it here. The first one, northeast, is not significant. But here it is significant, here is also significant. The difference here is that the first one is not significant. You can see the implication of weighting. Because weighting affects the distribution. So it will have implication of whether they will be significant or not. If you don't apply weight, you'll be talking about something different from reality. So that's one of the things that we should, that's very important in using this DHS data. We have been emphasizing that. So please notice. Now let's interpret this. For the first one, you see rural, V025, that's place of residence. You see rural, we just interpret this first one and we'll go. Are we together? We are not together. I think we are doing something else.
We are right, we are penning down.
We are penning down.
We're just jotting what you just said.
Oh, okay. But what I've just said, I've been saying since.
Maybe know about the code for waiting videos.
Okay.
But I'm actually one of those people that don't wait when I'm running.
Okay, let's interpret together after you have done that. The first one, see, look at this variable. This V024, that's region. Would you say region? Look at it. The first northeast is not significant. The last one is not, but the ones in the middle are significant. Would you say region is significant?
Yeah.
Huh? Would you say region is significant in this situation? I'm not sure. It is significant. Even if it's just one of them that is significant, that variable is significant in this model. Are you with me? So for the first one, let's just interpret that. Okay, maybe we can interpret the last one. Is it the same? Me, I like interpreting variables that are significant in my results. I'll just mention the other one that this is or not, but those ones that are significant, you want to press it on very well. Let them know that you did something that.
Okay, I might.
Oh. So the first one, which is 1.98. The odd ratio for rural against urban. Urban here has been made the reference category, and so we are looking at the ratio the comparison between urban and rural in respect of ever giving birth to at least one child. You remember that one child is the what? At least one child is the one of our is our focus, right? The one that is coded 1. So we'll be interpreting with respect of that category coded 1. Okay? Now, the next thing you are going to do after this, the next thing you are going to do is to, after identifying your odd ratio, the next thing you are going to do is to look at the significance of that odd ratio, which is 0.000, less than what? 0.05. Is that not so? And then look at the confidence interval. You have 1.45.
The reference category.
That's my question.
Did you choose it?
How do you
Or automatically
drop the
You can actually choose it. When you go, you can select which one to select. When you explore this with point and click, you will see it. It will tell you the options. But the thing is, the system itself automatically picks the first one. It automatically picks.
Not central for.
Yes. Anyone that is the first. In SPSS as well, you can select whether you should pick the first or the last. Here also you can do that. Not lowest. The first in the category that you have.
In terms of the attached code, this is 1 and 2, right? Urban is 1 and rural is 2.
I can't remember which
So it
one.
just picks the one with the. I'm saying that reality is right.
Actually, what I would have
This is not
preferred.
central 1, not this 2, not west.
For me, as a statistician, what I would have preferred is to run a univariate analysis and look at the one with the lowest frequency, so that all my interpretations will be based on the lowest one or the highest one.
Okay.
As the case may be. But if the package does not give you room for that, because by default, I think Stata will pick number 1.
Yes, to pick the first one.
By default. So you can then change it. But don't just forget that you are making your conclusion in reference to whatever the RC is, the respect category is.
Thank you, sir.
I don't even know some of these things. Even me. All these tests here. So let's interpret and you can do the rest when you're free. So the first one is 1.98 and then rural is 1.98 against urban, which is 1.0 and is significant. What does that mean? Yes. What's the interpretation of this 1.98? Oh, okay.
In rural,
Okay.
it plays the odds of having ever given at least a child by this much, 1.98.
Interpret it.
That's the odds now.
Yeah, rural residents
for every
have 98% higher odds of having at least a child compared to urban residents.
Higher odds, 98% higher odds.
Yes.
I think if you are already converting to percentage, then you can't say odds.
98% higher odds,
not odd ratio.
not odd ratio.
Odds ratio. Now that's very like higher probability.
Yes, they have higher 98% higher probability of, but don't call it probability, call it odds. They are different. Odd ratio, odd is not probability. Yes. Some people will say they are likely to have more likely something, but it's wrong. You see it in the publication, it's also wrong. But of course, people still accept it. So, but it's not really likelihood.
I think the margins that people actually use percentages, and that's why it's easier for to just stick with margins because it's easy to
To picture.
probability. probability of.
But the actual, but the actual interpretation is just a rural residents are 98 have 98% higher. 1.98. The thing is when you say ratio, if I say A over B, the ratio of A over B is 1. What does it mean? That A and B are the same, they have the same number. Is that not it?
Yeah.
So if I'm saying urban over rural is 1, I'm saying urban and rural are the same. But if I say rural over urban, the result we have is 1.98. What does that mean? Rural is higher than urban by 98. Is that not it? So if I convert that to percentage, I'm going to say 98% higher odds. You get what I'm saying? Don't stress me.
That's 0.9.
Why are you twisting my head again?
We want to be sure now. Process is important.
But you understand now? We are good to go. So, if you now put everything together, you say they have 98% higher odds or increased odds, or you can also put the statistical significance. They have 98% statistically significant higher odds. You know, for them to show that yes,
Speaking or you write it?
you run it yourself. Yes. When you now say 98% statistically significant higher odds of having at least one child compared to urban residents, you now put the p-value, you quote it. Odd ratio 1.981. You put semicolon, say p-value less than 0.05. You say, you have done well. Maybe they will say maybe we should employ this person. It's like you know what.
He's saying less than 0.005.
P-value less than 0.05. No, but it's less now. See.
Some people say you should put the exact.
You want it to be equal to 0.0.
In articles, you are saying some people say, how many articles have you seen where they actually write the exact value?
They do.
No, some do, but most of the ones you see, it's just they say p-value less than 0.05, depending on the level of signal you have chosen.
Confidence interval.
Confidence interval is there as well. You can use it to interpret it. Of course, when you are putting your table, read articles to guide yourself regarding that. I think we have done well. Please clap for me. What is left, sir? Which one is others? You can interpret others based on the first one. All you need to do is just pick the first one and relate it to the first one that was taken as the reference category. In this case, it's what? North Central. So what will you say? This one is not even significant, so I'm not looking at that. Let's look at the next one. Because if something is not significant to your study, what's the point of talking about it?
No, it's important.
No, you will not talk about it the way you talk about those ones that are significant. Even this thing is tired. Okay, it's not tired. So yes, of course, it's not like you disregard them completely. That's not what I'm saying. Because of course you have to tell them about, okay, this is your model, these are the ones that are significant, these are the ones that are not, and then you talk more about those ones that are meaningful, you know, how they can use it to, I think you understand this. So here, how do you interpret this? Thank God this is there. It's 0.12 and it is also significant. How do you interpret this based on what we did the first time? This, the second one, 0.12. How do you interpret it?
What is 0.12?
The second one, northwest.
Really, the northwest
Yes.
reduces.
When you place rural over urban and it's giving you something less than 1, what does it say? Rural, if you place northwest, if you place northwest over north central and you are getting something less than 1, what does that mean?
It is less like
Mean that north central is higher than northwest, is that not it? That means northwest is lower than north central. So how do you interpret this? Residents northwest
more likely to have
less.
They are more likely to have
Less likely.
Less actually, but I don't like using likelihood. They have reduced odds.
Lower.
Reduced odds, statistically significant reduced odds of having at least a child compared to resident of North Central.
North Central is the reference.
North Central is the reference category. Is it clear now? It's clear. You are just not talking. I know it's clear. So, let me see. I think we are done. Yes, we are done. Thank you for showing up and for listening. Any question?
Yeah.
Yes.
Who said yes? You can't have questions, sir. It's late.
I have a question.
What's your question? Okay. Let's finish. You understand this now, so don't worry. Just. Oh, okay. You are not leaving to a hotel. Let me answer you. These people are going to a hotel. I'm taking care of them.
Data set here so that I will mark it when I get home.
This is the data set. You see .dta. See,
Yeah.
.dta. That's the data set.
So is the DHS data set 2018?
Yes. But go and learn how to download your own data set. You are not going to use. You are not going to use this data set and give it for analysis. So.
I requested for
Because any analysis you are going to do with DHS, you must get approval. Yes. Don't go and collect data from somebody and do. No. No, you can't collect data. No, you can't use that data. Sir? It's just rhetorical because I know you don't have questions. How will you have questions with all these things that we have got? Okay, sir. Let's just.
You wanted to tell us about equal variances and zone or something like that.
I was trying to. It's similar to assuming equal means. It's similar to assuming equal means. When you assume that the means are equal, what are you essentially saying? That there is no difference. So when you assume there is equal variance, you are saying there is no difference. So it's just a kind of way of stating the hypothesis. So when the variances are not different, then you are saying that's your null hypothesis. So you just go there and look at the parameters there to interpret your results. That's it. Can we clap for me? See, they are not clapping well. See this madam, and I stress myself. For you. You did not clap for me. Yes, we are done, sir.
Who are the people that clap for him?
It's not easy.
By force.
What if we are not going to go already?
I actually enjoyed today's class.
You impose it on them.
Today's class is more interesting than yesterday. Yesterday was so